Wow. All right. Okay, let's do a very quick, less than 1 minute review on what we did last class. Okay, remember that Bobo, Bot, and Betsy are ways to find what the ends of the graph are doing. If it's a Bobo, what are the ends getting closer to? Zero. Very good. If it's a Botan, the ends are not getting closer to anything, so they're either going up or down, right? Okay, but not towards a specific value. Okay, then if it's a Betsy, your ends are going to be evening out towards whatever the coefficients divide to. So in the example I gave you last time, it was 10 divided by 2, which was 5. Your graph evened out to 5 on the ends. You remember it? Yeah. Okay, turn the page. We also talked last class about different types of functions, and we put them in order from smallest to largest. So if you look at the back of the next page, we said that sine and cosine are the smallest, then your logs, then your polynomials, and then your exponentials, yeah? Okay, turn the page one more time, ready? And then there is, oh, that question. So I think it's see if okay. All right, refocus for me, please. Turn the page one more time. Okay, we also talked about that there are 3 weirdo functions that your limits to the left and the right towards infinity and negative infinity can come out different. Okay, and those types are absolute value, square roots, and exponentials. Oh, well. Okay, absolute value, square roots, and exponentials. And if you remember, last class, we left off in the exponential section. So if you'll turn the page again. Okay, exponentials have a weird property. Okay, and the property is that when you put a negative into an exponent, do you remember that it turns that term into a fraction? So we're going to pick up from there with your notes. We did this whole page. Turn to the back, you should be on number 32. Okay, number 32, are we ready? Okay, wow, that was so good. Perfect. Okay, number 32. X is going to infinity. Is it? Are you ready? A Bobo, a Botan, or a Betsy? Okay, I've heard all of the 3 answers. Okay, let's look at the top. The top is a power. And the bottom is an exponential. Okay, remember that you are picking the biggest thing on top. Okay, the biggest thing on top versus the biggest thing on bottom. So which is bigger? Powers or exponentials? Exponentials, that makes this a Bobo, which means that it goes to 0. All right, take a look at number 33. This time, your x is going to negative infinity, which when I plug that into 4 to the x, is going to turn it into a 1 over 4 to the x. So let's rewrite your limit. It's 6 plus 2x5 over. And then as soon as I hit your weirdo function, 4 to the x, now it's a 1 over 4 to the x plus 3x5. Okay, and then I told you last time, once this is a fraction, it's not exponential anymore. You're not ever going to pick it as the winner. So if I'm looking at the top, 2x5 is still the highest. But what is the highest on the bottom now that 4 to the x is out? And now, is it a Bobo, a Botan, or a Betsy? Now it's a Betsy. They're both x5s, and I divide the numbers in the front. my limit's gonna go to 2/3. Now, the next two questions, if I were to ask you if it's a Bobo, a Botan, or a Betsy, okay, you might be tempted to say that it's a Betsy. The reason why is that 3 to the x is an exponent, 6 to the x is an exponent, and so if they're both exponentials, usually you would pick Betsy. Okay, that's not the case. Read right here. Betsy only applies or exclusively applies when you're dividing polynomials. Okay, when you're dividing polynomials or powers with each other. So you can't have a Betsy of 2 logs. You can't have a Betsy for exponentials. You pick which exponential is bigger than the other. So on top, I have a 3 to the x. On bottom, I have a 6 to the x. Which one is bigger? 6 to the x, that makes it a Bobo, which means it goes to 0. Okay, so you can never pick Betsy unless it's an x power versus another x power. So x squared, x cubed, x cubed. Okay, same thing for this one. Okay, my x is to negative infinity. What's going to happen to my 3 to the x? 1/3 to the x. Very good. And then my 6 to the x is going to turn into a what? 1/6 to the x. Very good. And now that I've turned, basically I've wrecked both of my exponentials, what is the biggest thing left on top? A plus 10 divided by what? Plus 2. Okay, then 10 divided by 2 gives us 5. Okay, but your exponents end up out of the running because a negative infinity on an exponential tanks it. Okay? All right, let's go to our next section. So now we have limits that are going to infinity and there's other stuff around it. If you remember when we did properties of limits, okay, your limit is always going to jump in to where the x is. So in this case, I'm going to find the limit as x approaches minus infinity of 6/x. And then when I have that answer, I'll cosine it. Okay, so think about if that makes sense. Your limit is going to jump to the center function. And then once we know that answer, we'll cosine it. So 6/x, think about it. Is it a Bobo, a Botan, or a Betsy? Okay, it is going to be a Bobo. 6 is a constant. X is a power, and powers are bigger. So this is a Bobo, which means that it goes to 0. Then I want the cosine of 0. Okay, and we learned how to do that with your hand trig, like the first day of class. So let's review that real quick. Which finger is your 0 finger? Oh, not your thumb. Pinky. And then where are your cosine fingers? Above or below? Cosine's above. And then remember, you square root it, put it over 2. How many fingers are above your pinky? So it'd be root 4/2. But what is the square root of 4? 2/2, which gives me a final answer of 1. Okay. All right, let's take a look at the next one. We'll do 2 more and then I'll give you a chance to try some. Okay, number 37, I have a limit as x goes to infinity, but it's going to jump up to where the x is. So now I have e to the power of 3 plus the limit as x goes to infinity of 1/x. So as soon as I see where my x is, my limit jumps right into there. Okay, for 1/x, is it a Bobo, a Botan, or a Betsy? It is a Bobo because 1 is a constant, x is a power. So that's going to give me a Bobo, which means that that number is what? Then I have e to the power of 3 plus 0. Okay, 3 plus 0 is how many? Then it's e to the 3. Okay, so the limit jumps right to where the x is. You'll do that part first and then plug it into the bigger formula second. Let's do 38. My x approach infinity. is gonna jump right up here with the 1 over x. So I have 7 minus 3e to the power of limit x approach infinity 1 over x. And that limit is gonna snuggle right up to where the x is. Okay, what is that little piece gonna turn into? Is it a Bobo, a Botan, or a Betsy? Another Bobo, which gives me what value? 0. So I have 7 minus 3e to the 0. Question, can I just cross this whole back part off? No. E to the 0 is what? Kind of. What's anything to the 0? Anything to the 0 is 1. Okay, so e to the 0 then would also be 1. Okay, and then remember here, you're going to follow PEMDAS. So we did our exponent first. We're going to multiply second, and then we're going to subtract. What's 3 times 1? 3. 7 minus 3 is 4. Okay, can you try the next row? Okay, let's do it. So rewrite it where your limit is snuggled right next to where the x is. So it'd be the limit. You're going to put limit x to infinity of 1 plus 2x, and then the plus 3 will do later. Okay, like this. So you're going to have LIM. So this is going to apply only to this first, because the plus 3 doesn't have an x with it. So I'll find the limit as x approach infinity on 1 over 2x, and then I'll add 3 to that. So your limit is going to jump to whatever part of the equation has an x. Does that make sense so far? Okay, then from there, 1 over 2x, is it a Bobo, a Botan, or a Figure on the bottom. Figure on the bottom, which means it goes to what number? And then what's 0? This whole thing is a 0 now, plus 3. Okay, so now let's try the next one. So this time, where's your limit going to jump to, the 10 or the 6x over 3x? So it'll be 10 minus, and then you're going to work out that limit. X to infinity, 6x over 3x, just like that. Does that make sense? And then will that be a Bobo, a Botan, or a Betsy for the 6x over 3x? It is going to be a Betsy because they're both equal powers, right? X versus X, that's a tie. And do you remember what the GC stands for? Divide what? The constants in the front. So if it's a 6 divided by 3, how much is that? That's or not? See how those x's are little? Those are exponentials. So you can only rewrite here, Betsy only applies if they're polynomials. So like a 3x and a 6x, those are polynomials. Versus what do we call 3 to the x and 6 to the x? What type of thing? Because the x is little at the top. Yeah? No, this is the drop sheet, but don't do it. We don't want that. You're not doing that.
Because she was like, you don't want to get out of some you're making silver right now.
Okay, yeah.
Let's see. That's why I said figure about it.
Read this through, but you can only Betsy if you're dividing.
Finish the last one.
So 2x to the 5 and 3x to the 5, and these are both that parts. Versus what type of equation is 3 to
Anyway.
So in that case, you can't Betsy, you have to think who's bigger out of it. Okay?
Anyway.
All right, so now you do it exactly right.
Everyone would have a different.
Okay, good, that's about right.
I thought it was that way. I'm not doing that. You know, so you're taking a guy over there with you just fine, bro.
You have it right. So this is the bubble, right? And then it's 3 plus that.
But that means probably.
The only reason this one having
So like they.
you know what I'm saying, so you don't have the.
Yeah, so-
Written already, then it's not.
Oh, the last, I didn't get from it.
And then this one, just this.
Yeah, I mean, that's hard.
Oh, you don't. Then the front is n minus. So that value replaces the limit.
Cause it's just actually what each one is.
What y'all get?
I got
Okay.
I got
Why is this?
Cause the 10 doesn't have an X. Now, okay, let's say you did put the limit of 10 minus the limit of 6x over 3x. That's fine, but the limit of a constant is just gonna stay the same. So that's why, like, if it's just a 10, you don't really need a limit on that. But if it has an X in it, you need one. Does that make sense?
Different ways.
Let me see how you wrote it.
Why?
That's fine. Well, what is this? Oh, you were racist, okay. Yeah, that's fine. Okay, so then for this piece, is it a bobo, or Betsy? Which means it goes to 0, right? So then this whole thing is 0 plus 3 more. Good job. Okay, you should have gotten 3, 8, and 9. If you got them, go to the next row. 3, 8, and 9. Next row. Wow. Yeah.
Oh my god, I haven't even studied for a test.
Wow. Okay, but
It's
next
Friday.
it's this one. Not 6. See how this is up. And what's anything to the 0? Yeah, but you did the work right. You just mess up the very end. Yes.
What if this next one is 0?
It is a bobo.
It's almost the way that I have to do. But I have one on Friday, so I'm probably.
Central. No. This.
Number 7 is what I'm doing. Sorry. Anyway. This is right.
This one's not right. It's 10 minus 2.
Oh, I didn't even like that one.
So then it'd be
I told you.
10 minus 2. Yeah. Okay, are we on the next row?
Yeah.
Okay, so do you notice that on the next row, your X is already built in to be negative? Do you see that? So if there's a negative here, what happens to this? It flips to what? 1 over 6 to the X, right? Plus 2. And then on the bottom, I have a 3X plus 4. Okay, which part of that is bigger? Is it the top or the bottom? Bottom, and that makes it a? No. Bottom is bigger on the top. Bobo. Okay, and then that means it goes to 0. Good. Now look at the next one. Will my 6 to the negative X end up turning into a fraction here? Why not? That's correct. If I take a negative and I put it next to another negative, now it's just a regular 6 to the X, and we don't have to flip that. So now it's 6 to the X plus 2 over 3X plus 4. The top is, do you remember the name of this type? And the bottom is a power or polynomial. Those are the same. So who wins? Exponential on top or power on bottom? Good. So then it'd be a bottom, which means the limit is what? Okay, one more left. See if you can do it. Okay, your answers are up here for the first few. Okay, we said this was 3, 8, 9.
Yeah.
Okay, on the bottom row, You should have gotten 0, then DNE. Okay, this one has a negative built in, that's gonna fraction it. Versus on 43, you're applying a negative to another negative. So it's actually gonna stay a 6 to the x and the negative crosses out. Okay, for your last answer, you should get 1. Okay, see if you can get it, and then we're gonna go to the next page. Yes?
So with this, change that. So these are the ends.
So that's on the bottom.
Because remember, the limit jumps in with the 1 over x. You're gonna ignore the 6 at first. So it'll be like this. You'll have 6 to the power of limit x minus infinity 1 over x. So remember, the limit is gonna jump right up there up top. And then what is this?
Oh. Say this one.
Okay, but pretend the 6 isn't there. What type of limit is that if it's 1 versus x? It's a bobo, which means the exponent's what?
Oh, 6 to the 0.
6 to the 0, very good. And then 6 to the 0 gives you what?
It's honorable, like,
Because think about on top 1 is a constant and x comes call it a even though it's only x to the first, it's not even x squared, it still beats 1. Does that make sense? So if you go back to that order, constants were the smallest, then logs, then powers, x powers. So that makes it a bobo. And then I take, that means it's a 0, right? Then I take the 0 and I plug it into the 6 to the power of 0. And that gives me the 1. Good?
I have a headache. I don't know.
Yeah.
Ibuprofen or something.
A what?
Ibuprofen.
Oh, ibuprofen?
Bro, it's my accent.
Yeah, you said that so exotically. I've never heard it called ibuprofen. What is it? Is it for a headache?
It's the same, push through. No, it's really good.
Rebecca, no, like have to they get to the speaker. Okay. Okay, we have 2 things left to cover. So if you will, please, okay, turn to the last page or the next page. Okay, the last section of your notes asks you to find horizontal asymptotes. Okay, girls, are we ready? And so remember that horizontal asymptotes, you have 2 ends of your graph. The way you are going to find them is looking at x to infinity and x to negative infinity. Now, if you turn back in your notes, okay, you'll remember, we talked about it in our review, okay, that you only have to worry about these 3 types of functions. So look on the board. These are your 3 guys, that if one of them is in the equation, your ends might come out different. But if you don't have any of these 3, you don't have to worry about each end separately. So take a look at number 45. We are going to check both ends separately because which of your weirdo functions is in number 45? The e to the x. Very good. That's an exponential. So we are going to check the left end first, which is going to be the limit as x goes to minus infinity. And then we're going to check the right end second, which will be as x goes to positive infinity. Okay? But again, the reason you're having to check both ends is because you have one of the 3 function types where they're allowed to come out different. Okay, let's start with the left end. X is approaching negative infinity, and it's going to jump in where the exponent is. So I'm going to take my negative infinity. I'm going to slide it in right here. what is gonna happen to my e to the x if I have a negative infinity on it? It's gonna be a 1 over e to the x, right? Yes? Okay. From there, my e to the x turns into a 1 over. So now when I'm looking at my equation, this piece right here is either a Bobo, a Botan, or a Betsy. On the top, I have a 3 times 1. On the bottom, I have an e to the x. Who's bigger? E to the x, which means it's a Bobo, which means this piece goes to what? 0, but then it's 7 minus that. What is 7 minus 0? 7. So the left end of the graph curves off to 7. Okay, because it was 7 minus, and then this came out to be a Bobo. Because it was a 3 times 1 on top is just a constant, but an e to the x on the bottom is exponential. Okay, now let's do the right side. If x is going to infinity, is this going to fraction? No. So what I'm going to do is I'm going to make it a fraction by just putting it over 1. And then I'm going to compare who's bigger, the top or the bottom. E to the x is on the top, exponential is the biggest type. That means that this one is a Botan. Does it have a horizontal asymptote? No, that's what the n stands for, is none. So the left end of my graph curves off to 7. But the right end of my graph doesn't have an asymptote. Here's what your delta math is going to say. It's going to ask you how many horizontal asymptotes. You're going to circle 1. Now for your homework, it's a little drop down menu. You'll click 1 horizontal asymptote. Then it's going to ask you to write the asymptote. You'd put y equals 7. Okay, because horizontal asymptotes are flat across. If you remember, it's a HOI. So it's balancing out to 7. That means y equals 7 is the line it's getting closer to. Okay, take a look at number 46. First question, does it have any of the 3 weirdos in it? No, the 3 weirdos are exponentials. Does it have any of those? No, no square roots, no absolute values. So that means that I can check both ends together. It doesn't matter if I'm going to infinity or negative infinity, it's going to come out the same. But it's not a fraction. How can I make it a fraction? Put it over what? 1. And then I would say, okay, if all the crap is on top and it's just a 1 on the bottom, is it a Bobo, a Botan, or a Betsy? It's going to be a Botan. And do I even need to check the second end? No, because if it doesn't have one of those 3 function types, you don't have to check the end separately. So in your drop-down menu, you would say this has 0 horizontal asymptotes. Okay, take a look at number 47. Does it have a weirdo in it? Yes or no? Yes, which one? E to the negative x. So we're going to check the left and the right end separately. Remember that for the left end, x is going to minus infinity. For the right end, x is going to positive infinity. Okay, now, quick question. Write that down and then just look up and think about what I'm about to ask you. Okay, one of these is going to end up where the e drops into a fraction. Normally, it's the negative infinity. Is that the side that's going to turn into a fraction here? No, because why?
It's already negative.
There's already a negative. So if I put a negative infinity into a negative x, what's going to happen? Good. So I'm going to have a 4x minus 5 times an e to the regular x. And if I put all that over 1, how's it going to come out? Bobo, Botan, or Betsy? That's going to be a Botan. Okay, because the negative fixed itself. Versus when x goes to infinity, my negative that's built in is going to do what? Turn this piece into a fraction. So I'm going to have my 4x minus 5 on top times a 1 over e to the x on bottom. And then as I'm scanning that fraction, I see that the top is classified as a power. What's the bottom? Exponential, so is it a bobo, a botan, or Betsy? Gonna be a bobo, which means that side goes to 0. Very good. So y equals 0 on the right, but no asymptote on the left. So you would circle 1 asymptote and then type in y equals 0 for the bobo. Okay, let's do maybe 2 more. Let's do number 48 and then number 50. Okay, take a look at number 48. Does it have a weirdo? Yes. So we're gonna have to check each side separately. Let's do the left first, which is to negative infinity. And then the right side second, which is to positive infinity. Okay, and also let me say, I know it's really annoying to write this over and over again. For your homework, I don't care if you do it, but for your notes, I do it correctly so that when you take a test or a quiz or whatever, you can look back at it and remember what you're supposed to do. Okay, for negative infinity, what's gonna change the way that I write this? So it'll be 3 minus 1 over e to the x over x minus 2x cubed. Okay, because negative infinity on an e to the x makes it a 1 over e to the x. Then from there, I'm going to circle the biggest thing on top, the biggest thing on bottom. Should I circle e to the x for the top? No, what's the biggest thing on top now? Just a 3 versus what? 2x third. Which one's bigger? Bobo, Botan, or Betsy? The Bobo, which means it goes to 0. Now let's check the right side. X to infinity is 3 minus e to the x over x minus 2x cubed. Okay, why didn't we fraction the e to the x? There's no negative up top. Very good. Then is this one a Bobo, a Botan, or Betsy? E to the x is bigger than x cubed. It is a Botan, which is dne. Okay, how many asymptotes then does this one have? Only 1. Okay, yes?
Do you explain why we had to make that one, fraction over here again?
It's because x is going to a negative infinity. And whenever you put a negative in an exponent, it turns it into a fraction. So like e to the x will become 1 over e to the x. Okay? All right, last one like that. Take a look at number 50. Are we going to need to check both sides separately? There's no weirdos in it? There is. What is the weirdo term? 2 to the x. Very good. So I'm going to do x to negative infinity first. Positive infinity second. Okay, which one, left or right, is going to have a fraction pop up? Left, because if there's already a negative built in, then it would cancel out, but there wasn't. So it's going to be 4 plus 2x to the 50 over 6x to the 50 plus 1 over 2x. Now remember, once you fraction your exponential, it loses. So if I'm looking at the top, I'm going to circle 2x 50 as my biggest. What am I going to circle off the bottom? And if they're both x 50s, what do I do with the numbers in front? Divide. What is 2 divided by 6? 1/3. Very good. So my left side of my graph is going to curve off to 1/3. Now let's check the right side. Will I fraction the 2 to the x? Why not? Yeah, there's no negative. So it's going to stay 6x 50 plus 2 to the x. Okay, no fraction on the right because there's no negative into an exponent. Okay, then circle your biggest thing on top. What would you be circling? Which term? Okay, and what on bottom? 2 to the x. And which of those is bigger, Bobo, Botan, or Betsy? That would be a bobo, which means that side goes to what? 0. Okay, now, for this question, how many asymptotes do you have? 2. The left side is curving off to 1/3. The right side is curving off to 0. When you type it in though for delta math, you would put y equals 1/3 and y equals 0. Okay, if you do not put the y equals on the asymptote, it will count it wrong. Okay. How do we feel about that? Confused?
No.
No? Okay. We do need, real quick, we do need to go back and do this little section that we skipped, but I want to give you a little bit of time to do the delta math questions before we add in anything new. So I want you to go into your delta math and do the horizontal asymptote questions. Okay, the horizontal asymptote question. And then you have yourself. Yeah.
Wait, this is about because nobody's gonna come to the movie to the train. This is not more.
That's it. Thank you.
That's so disgusting to me. Like, why are you using these things?
There, do you pass? Here,
I'm every day.
You're doing all the horizontal asymptotes.
Cancel Valerie. Yeah, she's so late.
Okay, do not do the ones that say don't use DNE for your answer. That's the part we need to still cover. Okay, you should be doing these. It should say horizontal asymptotes with the analytic. That's also not. Those are the ones you do.
Why is it there with all that? Yeah, the rest of me left was.
It's because they were hidden.
Should we do everything but the?
You can do anything. Yeah, it should have adjusted. Yes. Okay. So you should be doing all of these at the bottom, the horizontal asymptotes with the analytic limits. You may need to refresh if it's your browser from last time. Okay. Can we go to the questions that we skipped? I think there's only 3 of them, and then we'll do maybe one off your notes together, and then you'll have the rest of class to finish. Okay? So go to number 7. Okay, so here's the deal on this section. Okay, remember that we said either your ends are going to 0 if it's a bobo, they're going to a number if you had to divide your coefficients. Okay, but the other option is that you don't have an asymptote. What would that happen for? Bobo, botan, or Bensy? When would you not have an asymptote? Botan is correct. Okay, so when you look at this section of your notes, these are all botans, okay? When you have a botan, let's say for number 7, I have an x5 versus an x2, yes? I can tell whether that end is pointed up or down by just checking the signs on infinity. If I take infinity and I raise it to the 5th power, will it be positive or negative? Positive. It'll be positive. What if I do x to infinity and I square it? Also positive. What is a positive divided by a positive? So this goes to positive infinity. Now, is it also true that it's a DNE because it's not approaching a specific number? Yes. But the section I had you skip in your delta math, it doesn't want DNE. It wants which way is it going? Is it pointed up or down? Now let's do negative infinity on the exact same one. Sure. Okay, so for this one, I have x approaching minus infinity. It's still a button, but let's check the signs. What happens to a negative infinity if I fifth power it? It'll stay negative. Okay, now let's take that same minus infinity and let's square it. How will it come out? Positive. And what happens when I take a negative and I divide it with a positive? It'll be negative. Okay, but notice that we're not checking every term. We're just checking. Okay, the biggest thing on top and the biggest thing on bottom. Okay, let's do this one. X to infinity. Is it a Bobo, a Botan, or Betsy? Botan. So I know the limit doesn't exist, but I can be more specific and say if it's going up or down. Let's do a sign analysis. Infinity to the fifth, positive or negative? Positive. What about infinity cubed? Positive. And if I divide two positives, what do I get? Positive. Positive infinity. Okay, now let's do negative infinity. What's negative infinity to the fifth? What about to the third? But if I divide two negatives, how does it come out? Positive infinity. So notice that on the first example, they came out opposites, but on the second example, they ended up being the same. Okay, last one. X to infinity on top comes out how? What about on bottom? Divide two positives, get a positive. Okay, last one. Negative infinity, same equation. Negative infinity cubed comes out negative, but the bottom comes out positive. Divide a negative and a positive, get a negative infinity. So they're all DNEs, but you can tell which way that end is pointed. So now let's do one of those together. Okay, so go back to your delta math, open your computer back up if you need to. Okay, and let's do just the first one. Okay. What is x approaching? Negative infinity. And is there a weirdo?
Yes.
Yes, so we're gonna take e to the x and make it 1 over. We're gonna be kind of lazy. Okay, just pretend. 1 over e to the x. Now, what's the biggest on top? What's the biggest on bottom? 4x. 4x. Is it a bottom? Yes. Yes. But the title says don't put DNE. We want to be more specific and say, is it going to infinity or negative infinity? So if I take a negative infinity and I cube it, will it stay negative? Yes. Yes. What about if I take a negative infinity and I times it by 4? It'll stay negative. What happens when you divide though two negatives? Comes out positive. Okay, so for that section, don't put any DNEs. If it's a DNE, you need to pick which way it's going. Okay, but for a Bobo, it'll still be Bobo. For a Betsy, it'll still be a Betsy. Okay? So see if you can do all the rest of it as we need to get 30 minutes. Yeah. If it comes out to a bottom, you'll have to tell an analysis, anything else. Oh, and after that question, so is it a bottom? X5 or X2, it is. Infinity. Infinity to the third. No, you actually are right. Oh, that. So it says minus infinity on top versus infinity squared times 3 is a possibility on top. So you're gonna be infinity. You're gonna go to the power of five, right? So you're gonna minus that. Yes.
So I was very clear on this one, and on the boards,
Okay.
right? How come it is?
Okay. So we're taking a negative infinity.
I thought we're.
With powers. So if it was x to the 4, that would be positive. But if I take the negative times the second, or if I took the negative, two negatives cross out, the second two negatives cross out, that's how it ends up being positive. Or, okay, is it the next question? Okay. Let me just put it up here. Okay, so first question, is it a box? It is, because if it wasn't a box, I'd be picking Bobo or Betty. It is a box. Biggest thing on top is, and we're doing X approaching infinity. Which means we're going to be positive infinity. Biggest X on box, biggest X on box. Let's do positive infinity to the fifth. How does it come out? Positive, but then I'm gonna times it by a negative 5.
We actually just communicated with
So how does the top get it?
Negative.
Negative. Okay. Okay, then on the bottom, I'm gonna take my infinity, it's positive, and I'm gonna square. Gonna stay positive, very good. Then what about if I times it by 3? So positive, so I have a negative on top, divided by a positive on bottom, how's it gonna come out? Negative. But it's still a bottom, you're just having to be a little bit more specific on which way it's going.
I don't, yeah.
Uh-huh. Yeah. Well, hold on, so when you do what you just said, you'd have 1 plus, and then wouldn't it be a 1 over e to the x? And then what's on the bottom? Plus 6? Okay, what's the biggest thing on top now? A 1? What's the biggest thing on bottom? So is that a bottom, or you have a big infinity or negative infinity? It's a what? Which means it's 0. So you're only having to choose between the infinities if it gives you a bottom. If it gives you a Bobo, you still pick 0, Betsy, you still divide the Bobo. Y'all all have the same set. Are y'all all in the? Yeah. Oh, okay. Alright, so 2x plus 4, e to the negative h, and then which way are you going? Okay, so first question, if I take the negative infinity into negative exponential, do I fraction this or no? No, so let's just pretend that it's positive. They're gonna get some, right? So is it a Bobo, a Boston, or a Betsy? There's literally nothing on it. It's a Boston. Okay, so we know it's gonna be infinity or negative infinity. It's not a Bobo, it's not Betsy. Okay, let's do our negative infinity, times 2. What are we gonna get? A negative. Okay, and then e to any power, remember the sign? It's 50 positive. Do you remember the e to the x graph looks like this?
Oh, yes.
Right, so it never is e to anything. So you have your negative from here times e is always positive. What's a negative times a positive? It would still be positive. Because think about your e graph. E never even hits 0. So your e can never be negative unless it's like minus e to the x, where you have it like this. Yes. Okay, so do you have any of your weirdos in that? Okay, so then you know you don't have to check both sides separately. Is there anything on the bottom? No, so that makes it a Bobo. Let's put it over one. Is it a Bobo, a Botan, or a Betsy? Botan, and then are you having to pick infinity or negative infinity? Plug it into only your biggest term. What's your biggest term? Okay, and then if it's a positive or negative, negative, and then flip it. Negative 4. Yeah, correct.
Well, no, but